So here I have a dryer relay board, and it's not turning on, and in the code here, it's a EPT58114, and there are some relays on this side here, and if you flip over the board, you'll notice that one of the legs, the solder joint's fried. So it could be a bad relay or that. First, let's resolder that. If you go into Google, you can find this part as well. So you can see it's a 20 amp switching relay, and the relay is activated at about 24 volts DC. There, let's try to find the schematic. So the very first digits here are the voltage. It's right here. We have the relay switching between the two contact legs, or one, depends on the type, and then between these, this is the coil. So this is the activation coil right here. And yeah, so let's have a look. So for my version here, I have the two legs here. This is the one, 2, 3, and then the one leg here. That's the same as this guy here. So you have 1, 2, 3, and then the one leg there. So we can test this out by putting a small amount of voltage, like 5 volts between here and here. See if there's a contact between this guy right here and this guy right here. This will verify if that relay is still working. So you can hear it turn on. So I have my two probes. We're going to so that relay is fine. So you can see the main configuration of a relay. You have a flywheel diode, and the VCC connects to the negative of the diode. I have the board under the scope, and the little flywheel diode is that little black guy there, and this is what it looks like. You can see this is the negative side of the flywheel diode, and this is the positive. So you want to make sure that the VCC follow this trace wherever it goes, and that will go to the positive, and this side will be the negative. And this uses a low voltage. I'm using power supply. I use 5 volts, and then you can just make it like 500 milliamp. It's there so you don't blow anything, to verify that it works there. So